Microsoft just showed that brains beat brawn in AI, training a compact reasoning model in a single week. That outperforms behemoths hundreds of times larger, and that's just the start. They also unveiled a lightning-fast voice model that can spin up a full minute of natural speech in under a second. Plus their first fully in-house foundation language model now making its way into Copilot. This is the moment the size race gives way to the smarts race. Here's the twist that changes everything. For years we've pushed large language models to think longer, adding more steps and hoping the right answer appears if we just let the model ramble. The problem? If it takes a wrong turn early, it usually digs itself deeper, confidently explaining the wrong solution all the way to the end. Microsoft's team took a different route. Instead of forcing longer chains of thought, they taught the model to use tools, check its work, and adapt in the middle of solving. Think of it like handing the model a calculator, a scratch pad, and a sandbox. Faced with a math problem, it can write short snippets of code, execute them in a live Python environment, look at the output, and decide whether to keep going or change direction. That feedback loop makes it robust. It's not locked into one brittle path. It probes, verifies, and corrects as it goes. Of course, that creates a new challenge. Scale. Training a tool-using model means handling a torrent of code runs during learning, not just at inference. We're talking tens of thousands of execution requests happening simultaneously. If you fire those off naively, your GPUs sit idle waiting for results and your training pipeline crawls. So the team built the plumbing to match the idea. They designed a distributed execution system that can process around 45,000 concurrent tool calls with subsecond latency, isolated from the core training loop so the model keeps moving. They balanced loads across CPU workers and, crucially, added a dynamic scheduler that looks at real-time GPU cache availability and routes tasks based on what's free. No hotspots, no idle silicon. The payoff is huge. They trained this frontier-level reasoner in about a week on just 64 AMD MI300X GPUs. But the secret sauce isn't only infrastructure, it's how they reward the model for reasoning well. Traditional reinforcement learning often prizes the final answer. Get it right and you win, even if the path was messy. That teaches models to brute force, not to think cleanly. Microsoft flipped the incentive. During training, they oversample initial attempts, filter out noisy, error-riddled traces, and give more weight to examples where tool use was efficient. Formatting was clean, and the logic was crisp. The model still sees failures, because learning from mistakes matters, but the positive reinforcement comes from clean, high-quality traces. Over time, that shapes a thinker that's not just accurate, but efficient. They also used a tight curriculum. Stage 1 didn't even let the model unspool long reasoning. It focused on following instructions and formatting tool calls correctly, under a strict token budget that forces concise strategies. Accuracy jumped quickly. Stage 2 loosened the limit to handle deeper tasks. Stage 3 filtered out easy problems entirely so the model could only train on the ones it hadn't solved. It never got comfortable. It kept sharpening the blade. The results speak for themselves. On tough benchmarks like AIME, this agent-level model reached scores in the high 60 to low 80 range across recent years, surpassing gargantuan systems like DeepSeek R1 while using far fewer reasoning tokens. That efficiency bonus isn't just about math speed. Even though the training diet was math-heavy, the model showed strong transfer to scientific reasoning and held its own on general alignment and safety checks. That points to a broader lesson. Tool-augmented training builds adaptable intelligence, not just memorized tricks. Peek inside and you see something even more interesting. Beyond the familiar branching where a model tries different solution paths, this system exhibits what researchers describe as reflection moments. Tokens that appear when the model is actively responding to tool feedback, like reading a Python output, spotting the mismatch, and deciding what to fix. That's a hallmark of environment-driven reasoning. Not just thinking longer, but thinking with the world. Now, while this is a breakthrough in reasoning, Microsoft also announced 2 homegrown models aimed squarely at everyday use. First, a new speech generation system optimized for speed, quality, and versatility. It can synthesize 1 minute of lifelike audio in less than a second on a single GPU. That means real-time assistants that don't lag. Podcast-grade narration on demand, and even on-device voices where you can't afford heavy cloud compute. It's multilingual, handles single and multi-speaker scenarios, and it's already sneaking into products. If you've heard fresh voice updates in Copilot or played with text-to-audio demos in labs, you've probably touched it. The big win here is practicality. Competitors often need multiple GPUs and complex pipelines. Running this on one GPU changes who can use it and where it can go. Then there's the foundation model, Microsoft's first end-to-end in-house language model, trained at massive scale across roughly 15,000 NVIDIA H100 GPUs using a mixture of experts architecture. This isn't a showpiece for raw power. It's tuned for instruction following and conversation, the stuff people use every day: writing, Q&A, summarization, study, help, and drafting. It's starting to roll into Copilot for text scenarios, with a gradual rollout designed to gather feedback and refine before broad deployment. You'll also find it listed on public evaluation platforms alongside other big names, giving you a sense of how it stacks up in the wild. Zoom out and you can see the philosophy. Balance. Don't just chase theory or leaderboard glory. Build systems that are efficient, deployable, and useful. That's why they invested in the infrastructure to make agentic training fly, and why the new speech model runs on modest hardware. It's also why the foundation model leans into reliability and instruction quality rather than chasing the biggest possible parameter count. The theme across all three is the same. Smarter procedures beat sheer size, and tight engineering beats waste. What does this mean for the next wave of AI? Expect a lot more models that use tools during training, not just at inference. Expect token budgets to shrink even as accuracy rises. Expect voice that feels human in real time, not after a spinning wheel. And expect consumer-grade assistants to get far better at following instructions without making you repeat yourself. The headline is simple but profound. The age of bigger is better is fading. The next frontier is better feedback, better incentives, and better use of the compute we already have. Microsoft just planted a flag. Think with tools, train for clarity, deploy for everyone. If this breakdown helped you see where AI is heading, drop a like, share it with a friend, and subscribe for more deep dives. Let me know in the comments which part you're most excited about. The agent that checks its own work, the instant voice synthesis, or the new foundation model rolling into Copilot. Thanks for watching, and I'll see you in the next one.